Hello guys, welcome to the channel. In this video we are going to talk about recursion. First of all, what is recursion? Recursion is the way of solving a problem in terms of itself with some terminating condition, that is base condition. This technique is very useful in solving various problems of computer science, computer programming. Okay, consider this is an example of a sequence and this is the definition of this sequence. Okay, we are giving the solution. This is the solution. We are giving the solution in terms of itself, means 2 into f of this function, 2 into this function. We are modifying this function, we are decrementing, we are simplifying the function, and we that is the solution of this function. Okay, here we have same sequence. Consider this sequence. The explicit formula of this function is f of n, that is 2 raised to the power n. If we put n equals 0, we will get 1. If we will put n equals 1, we will get 2. If we put n equals 2, we will get 4, and so on. Here is the recursive definition of this sequence. This is our base condition. We are simplifying fn in terms of fn minus 1. Okay, this is called recursive definition. Means we are not giving direct solution of a particular function. Suppose if we give a direct solution, that is, suppose if we have function f of n, this is n, and we give direct solution of this function, that is 5. Sorry, this is 5. This is not recursive. We are giving the solution of this fn is in terms of itself, means 2 into f of n minus 1, means we have to find another f of n minus 1 in order to find the solution of fn. Okay, and if we find f of n minus 1, it will find another solution of another function, that is f of n minus 2, and it will keep going on till the base case when n becomes 0 and our value will be 1 and 1 will be returned. Okay, here you can see f of n, that is 2 of n minus 1, means 2 of 1 minus 1, that is 2 into f of 0. F of 0 is 1, it will be 2, and f of 2, 2 into 2 minus 1, that is 2 into f of 1, that is 2 into 2, that is 4. F of 3, that is 2 into f of 3 minus 1, that is 2 into f of 2, that is 2 into 4, that is 8. If we have to find f of 4, we have to find 2 into f of we have to find f of 3, that is, here you can see, if we have to find f of 3, if we have to find f of 4, we have to find f of 3, and to find f of 3 we have to find f of 2, and if we have to find f of 2, we have to find f of 1. Okay, and to find f of 1, we have to find f of 0, and f of 0, value of f of 0 is 1. That is our base case, and we will return from here, and value of f of 0 is 2, f of 1 is 4, sorry, value of f of 1 is 2, f of 2 is 4, f of 3 is 8, and we summarize After returning, we will get 16. Okay. I'm showing you uh, recursive function in programming. A function calls itself when a function calls itself with some terminating condition in order to solve a particular problem. It is called recursive function. Here, this is the recursive definition of this sequence, and I have written some code of this according to this recursive definition. Means when n equals 0, we have 1, otherwise we have this case. Here we have written n is the parameter of this function, and if n equals 0, we will return to 1, and otherwise we have this function 2 into myfunc n minus 1. Let me show you. If myfunc is 5, what will be the value? If we call myfunc with value 5, what will be the output? Okay, if we input 5 in this function, what will happen? This condition will be false, and this will be called 2 into myfunc 4. We can call this. Okay, and here myfunc 4 will be called, and when we call myfunc, it will be written 2 into myfunc 3, and myfunc 3 will be called, and it will return 2 into myfunc 2, and myfunc 2 will be called, and it will return 2 into myfunc 1, and myfunc 1 will be called, and it will return 2 into myfunc 0. This is here we reached to our terminating condition, that is our base case. When we pass 0 to this function, it will return 1. Here 1 will be returned. 2 into 1 will be 2, and we put here in my func1 this value, means 2. We put here 2. We will return to upper level. Here in this case we are going downward, and now we are going to upward. 4, and this 4 will be putted here, because when we called myfunc2, it will give 2 into myfunc1, and we put the same value 4 here. 2 into 4, it will be 8. And when we put 8 in this myfunc3, value of myfunc3 is 8, and we will put 2 into 8, that is 16, and we put 16 to myfunc4, that is 2 into 16, that is 32, and we will return 32 to myfunc5, means the value of this myfunc5 is 32. This is the output of myfunc5. This is how we call a recursive function. Okay, let us consider another problem, that is Fibonacci series. Fibonacci series is a series which adds previously two terms in order to find the next term. Okay, means if we have to find nth term, we have to add n minus 1 and n minus 2th term. Okay, this is the definition. If we have, this is the base case. If we have 0, n is 0, we are calling 0th term, it will return 1. Here 1, and if we have n equals 1, it will also return 1. Okay, now otherwise this is the definition of Fn. means if be called f of n, that is f of n minus 1 plus f of n minus 2. Okay, now we have f of 0 that is 1 and f of 1 that is 1. Okay, this is our base case. If we call here f of 2 is equal to n minus 1 means 2 minus 1 and n minus 2 that is 2 minus 2, that is f of 1 and f of 0 which is 1 plus 1 that is 2. If we call f of 3, that is f of 3 minus 1 and 3 minus 2, that is f of 2 and f of 1, that is 2 plus 1 that is 3. If we call f of 4, it will have f of 4 minus 1 and 4 minus 2, that is f of 3 and f of 2, which will be, we have find it earlier, f of 3 is, value of f of 3 is 3 and value of f of 2 is here 2. Just put these values, 3 plus 2, which will be 5. Value of f of 4 is 5. This is 0, 1, 2, 3, 4. Value of f of 2 is 5. Okay. According to this recursive definition of Fibonacci series, we have written this Fibonacci function. If we have, this is our base case, if we have n equals 0, we will return to 1, and if we put n equals 1, this function will return 1. Otherwise, we have this case, Fibonacci n minus 1. We will break down the Fibonacci n into Fibonacci n minus 1 plus n minus 2, and we will break down Fibonacci n minus 1 that further and Fibonacci n minus 2 further in again two cases, and we will keep doing that until we reach the terminating condition. Okay, here I have written the same. This is our respective Fibonacci function. This is a recursive Fibonacci function. This is our return value, and these are base case. Now we have to find Fibonacci f of 4. What we gonna do? We call 4 into this function fib4, and this condition will be false and this condition will be false, and it will return Fibonacci n minus 1 and n minus 2. Fibonacci n minus 4 minus 1, that is 3, and it will be divided into two parts, Fibonacci 3 and Fibonacci 2. Now Fibonacci 3 will be further divided into two parts, Fibonacci 2 and n minus 2 means 3 minus 2, that is 1, Fibonacci 1, and Fibonacci 2 will be divided into two parts, Fibonacci 2 minus 1 and 2 minus 2, that is Fibonacci 0. Okay, now we have divided Fibonacci 2 into two parts, Fibonacci 1 and Fibonacci 0, that is 2 minus 1, that is 1, 2 minus 2, that is 0, and we will return Fibonacci 1, that is 1, and Fibonacci 1, that is 1, and Fibonacci 0, that is 1, and here Fibonacci 1 will be returned at 1 and Fibonacci 0 will be returned 1, and this one will written here, and this one will be also written. If we add all these, we have 5 ones. Adding this 1 5 times, we will have 5, and 5 value of 5 will be returned to here. After that it will return here, and after that it will return here, and after that the value of 5 will be returned here. Value of Fibonacci 4 is 5, means if we call Fibonacci 1, it will return here 1 will be returned, here 1 will be returned, and here 1 will be returned. here 1 will be returned. Here in in the third level, this is the zeroth level, this is first level. In the this is second level. Okay, third, fourth. We have gone 0, 1, 2, 3, 4, fourth level, and we are going to upper level. Here it will return in Fibonacci 2, it will return this one will be returned and this one will be returned, means 1 plus 1, 1 2. In Fibonacci 2 we will have the value of 2, and in Fibonacci 1 we will have value of 1, and Fibonacci 1 this we will have value of 1, and Fibonacci 0 it will have 1. Now in Fibonacci 3 we have divided Fibonacci 3 into Fibonacci 2 and Fibonacci and Fib 1. The value of Fib 2 is 2 and value of Fib 1 is 1. If we add 2 plus 1, that is 3. Value of Fib 3 is 3. Okay, and Fib 2 is value of Fib 2 is 2. Value of Fib 2 is 2. Okay, if we add value of Fib 3 is 3 and value of Fib 2 is 2, we add these two, we will end up with 5. Okay, this is how we do we calculate the value of Fibonacci series. We have to calculate it on piece of paper, otherwise we can simply write the Fibonacci function and we can get the respective value. We have to understand it on piece of paper. You can do it in same way as I did. Okay, here is the definition. If we have to solve a particular problem in terms of recursive, mm, we have to solve particular problem recursively. We have to first write recursive definition. While writing the recursive definition, you should first write the main condition. This is the final condition, and after that, according to this main condition, you can write the base cases. Okay, so in this way you can write a recursive definition of a particular function. Okay? And this is how we write code. While writing code, we first write return statement, and after that we should write base conditions by passing some values. Please do it first on piece of paper and write this function on piece of paper. After that you should write the C function. Okay, hope you understand the concept of recursive function and how to write recursive definitions on piece of paper. Okay, thank you guys, thanks for watching. Happy coding.